All right. What do we have to do in number 1 to get how many sides it has if its sum is 1980? Divide by 180. Okay. Which is? Are we done? Why? Okay, why are we dividing by 180 and adding 2? What's the formula for the sum of the angles? I heard n minus 2, yes. What do we do after we subtract 2 from the number of sides? So if we're undoing that formula, you undo multiplication with the division by 180. We undo the subtraction in the formula with an addition. So you divide by 180 and you add 2 when you have the sum. How do I name a 13-sided polygon? 13gon, absolutely. Remember, you have those names on the front page of the notes from section 3-4. You have to know what number of sides goes with what word and vice versa. Anything over 12 is just a gon after it, as well as 11 is. Questions there? All right, then number 3, we got to name it by its vertices. Notice it said name it by its vertices. So I'm not asking you to tell me it's pentagon. What am I asking you to do? Name all the vertices. So what letter should I start on? E. Okay. Does it matter? No. So you can pick whatever letter you want. So you don't have to erase. You can pick whatever letter you want, but what do you have to make sure you do after that? Go in order. Stick one direction or the other. So which way do you want to go? Okay. Makes me have to go to D and then E and then A. But could I have done B, A, E, D, C? Yeah. Could have gone counterclockwise instead of clockwise. Could you have picked D to start with? Yeah, you pick whatever letter you want. So if you have something different than what I do, it is okay. Just make sure that you went all the way around clockwise or counterclockwise. All right, what object are the sides? What geometric thing? There's segments. Absolutely. So pick me a segment to start on. BC means I got to have a segment bar over the top. Give me another segment then. Okay, after CD comes, and then, and those also don't have to be in that order. You just have to have all 5. You could have the letters flipped around. So it could be CB or it could be BC. It doesn't matter which one you do. You just got to make sure you go all the way around. I specifically do it the way you guys named it off, because then I know when I get back around to the letter I started with, I got them all. But that's not a necessity. That's just me organizing myself. That's how I keep myself on track with those. But that's your call. All right, vertices. The name with commas, absolutely, because vertices are just the individual points. The name is telling me the whole thing as a whole. That's why we don't have any commas in there. Vertices are each corner individually. So we're separating them with commas. What changes then for angles? Angle symbol. Again, order does not matter on these. The symbols do. So having an angle symbol in front of all of those is important. So you should double check to make sure you have each of them. Could you have named them with 3 letters instead of 1 for the angle? Yeah, you could have. As long as your vertex is in the middle, you're fine. But you didn't have to, because there's only 1 angle at each vertex. So you can just leave it with the 1 letter. Good? Okay. Then we got that ACT. And one of the most important things I want you to realize on this is that you probably wouldn't understand the notation that is in the problem. So when it says the first 5 terms of a sequence are given in the table below, sequence is defined by setting a sub 1 equal to 9 and a sub n equal to a sub n minus 1 plus n minus 1 squared. Those are a lot of symbols that you guys probably don't even know. Even my Algebra 2 kids don't see this until the end of second semester in Algebra 2 after the ACT. But the key is realizing I don't care what those symbols are. I need to find a pattern that gets me the next term. So if you're looking at a problem like this and you're like, I don't understand what any of that means, don't skip it. It's just asking you to find the next term. You guys have found the pattern before. So what pattern is there? Not multiplying by the same thing each time, because 9 multiplied to get 10, 10 multiplied to get 14 doesn't make any sense. Not adding the same thing, because here I'm adding 1, but there I'm adding 4. So what pattern could there be if I don't multiply or add the same thing each time? We could subtract, but I think that's not the same either. Again, squaring. What am I squaring then? I see the 1, I see a 4. 14 minus, or 23 minus 14 is 9 there. The next one is 16, absolutely. So looking at those numbers, 1, 4, 9, 16, those are pretty important numbers. They have a pattern on their own. Those are squares, perfect squares. So square 1, I get 1 and I'm adding it on. I squared 2, I get 4, it got added on. Squared 3, got 9, added on. Squared 4, got 16, added it on. So what am I going to do here? Square 5. So you got to add 25. Which one is it then? 64. But most important thing there to realize is that you don't have to understand all the notation. You just needed to find the next term in the pattern. And sometimes that pattern's a little bit hidden, and you got to stop and think about what are these numbers? The numbers 1, 4, 9, 16, those should be numbers that you start to know, because we're going to work with perfect squares a lot throughout this year and throughout next year. So start recognizing those perfect squares. When it's 100% correct, you've double checked, you have work on number 1. You've double checked your segment bars and angle symbols on number 3, and you have some kind of work for number 4, then you can go ahead and pass it up. All right, if you don't have a straight edge, you're going to need a straight edge. There should be some in the bin in the middle. But before we go to needing that straight edge, we're going to talk about slope today. Slope is rise over run. How do I figure out the rise of something? What does that mean? If I'm counting rise over run, what is that telling me? Let's say again. How tall it is. Rise is how far up it goes. Okay. Run, how steep it is. So more a horizontal measure. So when you look at this next symbol, that triangle with the weird thicker side stands for change. The change in y's over the change in x's. If I want to know how far up it went, how tall it is, I count from one y to the next and say how many spaces have I moved. When we do that with a formula, that is really just subtracting your y's. So y minus y. Now, when you did it in Algebra 1, they likely put little subscripts down there and said y sub 2 minus y sub 1, or y2 minus y1. All that means is take the two y's of your points and subtract them. So I take the subscripts off at this point because I figure you can handle that part. The other thing is for the change in x, I would do the same thing, x minus x. The one thing you have to remember is that when you do that, each pair is above each other. So whatever y you pick first, you got to pick the x of that point first for the bottom. Is that okay? All right, I know you don't have colors on your paper, but this slanted one in the middle is your red one. And I want to know its slope. For on the graph, we're just going to count. Pick a point to start on. Count how far up it goes and how far over it goes. So if I pick those points that are already marked on the line for you, how far up does it go? How far over does it go? So my slope is 1 over 2. So a positive slope will always go up to the right. So positive slope is going to equal a number that's going up to the right, or a line that's going up to the right. What's the slope of that one going to be? Say again. Negative 2, 3. Why is it negative? All right, so we started here on the left, you had to go down 2 to go right 3. So down to the right will give you a negative slope. Now we did left to right on both of those lines. We started on the point on the left, counted the point on the right. Will the same thing happen if you go the other direction? If I started at this point on the right on the red line, where do I have to go to get back to the one on the left? What do I do? Down 1 over which way? Left 2. Is negative 1 divided by negative 2 still positive? Yeah, negative divided by negative is a positive. So you could have gone up and right, but you could also go down and left. Okay, what about on this one, the green one? What if I start on the one on the right? Where do I have to go? I heard up, yep, up 2, and then over which way? Left. Left is a negative direction. So 2 over negative 3. It's still a negative fraction. It does not matter where that negative sign is. So I could have it out in front like I just did. I could have it up with the 2. I could have it down with the 3. I could just have it in front. Does not matter. One of them went a negative direction. So up and right are positives. Down and left are negatives. Good? All right, then the black one. The black one's down here at the bottom of the graph. What's my rise? What's my run? What's my rise? 0. We're not going anywhere up or down. What's my run? 3. Between those 2 points, I got 2. Could you say 3? Sure, because any number, you could go to any point on that line. But between the 2 points that are marked, we had a distance of 2. What is 0 divided by 2? 0. So a horizontal line is going to have a slope of 0. One thing I need you to remember is why that happens. Remember that division and multiplication are inverse operations, right? So when I take 0 and divide it by 2, we say it gets us 0. I should be able to go backwards. I should be able to take 0 times 2 to get the 0 that's up there, which works, right? All right, so now let's look at the blue line over to the right, the vertical one. What's my rise between points that are marked? 2. What's my run? What's 2 divided by 0? I heard 2 and I heard 0. If I put 2 here, can I go back this direction? Can I take 2 times 0 and get back 2? Okay, if I put 0 there, does 0 times 0 give me 2? Okay, what number can I put there that I can multiply by 0 and get back 2? Say again? 2? And then I heard nothing. Anything times 0 is 0. There's no way to get 2 back. So can I divide anything by 0? No. So what do we say when we can't divide it by 0? Say it again. Not straight. What was back here? Okay, one more time. No, we just said we can't be 0 because 0 times 0 is not 2. No slope, undefined. No slope or undefined. I don't care which way you say it. Undefined is basically you can't divide by 0. No slope is you can't divide by 0, so there's no slope. I take either answer. But that will always happen with vertical lines. And the reasoning, again, is where the 0 is. If we are rising but not running, you can't divide by 0, so we have no slope. If it is horizontal, you are not rising, but you are running, you can divide 0 by anything. You just get back 0. So understanding where the number is the important part. Is the 0 on top or the 0 on bottom? Or where is our number, our ability to rise or run? Where's that value? Helps you figure out which one it should be. When you do your homework, you just have to read the directions on whether you only have to fill in the slope or if you also have to talk about whether it rises or falls, if it's horizontal or vertical. I think they're just fine the slopes. Yeah, they're just fine the slopes. So on to that end, these next ones I don't have a graph. All I have are the points. So I don't want to have to graph it then. So let's use the formula that's up here, which is y minus y over x minus x. Which one's x, which one's y in my points? Perfect. They're alphabetical, x comes before y. Whichever y you pick first, you're going to pick the same x first. In this case, does it matter? Because our y's are what? The same. So we're going to take -4 minus -4. Don't forget to have that extra subtraction in there. What do we put on the bottom then? Give me the x's. All right, what do we get when we do that subtraction? 0 over -8, which is an actual slope of 0, because 0 divided by -8 is 0, because 0 times -8 gives me 0. So you can undo the division with multiplication. All right, so tell me the formula on the next one. What would I put up on top? I heard 3 minus 1. That means she picked this point first up on the top. So what number's got to go first on the bottom? Perfect. -3 minus -3. You got to take the same point to start off on the top and on the bottom. Which gets us what? Say it one more time. Nice. Can I leave it like that? No. What do we have to write? Undefined. Okay, you got this? Go ahead and do the last two at your tables. When we look at that slope after we write the fraction and say, can I leave it like this? Can I leave 0 over -8? No, I got to simplify it to 0. Whenever you look at a fraction, always decide if you can simplify. always leave slopes in fraction form because the next step we're going to do is use it for graphing, which is more useful as a fraction. Do you all know how to get your calculator to reduce fractions for you? Fraction key. So in the second or the third one there, when you do the formula, tell me what numbers go where. Give me y. Over. Which gives you, if I want to reduce that -4/6 or 4/-6, however, wherever you want that fraction to be, or that negative to be, if you hit 4 and then your fraction key, and then the -6, or -4, fraction key, 6, don't care which way you do it, but there's an ABC button on your calculator. You put the 4 in, then the ABC, and then the 6, it's going to reduce that 4/6 for you. And what does it reduce it to? What is 4/6? And I don't care where that negative is. The negative could be up with the 2, it could be down with the 3, or just in front, doesn't matter. But your calculator can help you with that reducing. You don't always have to do that in your head. All right, so on the last one, what numbers did you put together? 0 minus -5 over 3 minus 0, which gets you to? Does that reduce? No. Now, some of you may have flipped it around. You might have done -5 minus 0. That would have given you a -5. But on the bottom, you would have had 0 minus 3, which would have given you a -3. Negative divided by a negative is a positive. So it does not matter which order you do those in. Good? Okay. Then the next thing we're going to do is start applying that slope using the slope-intercept form of the equation. When you look at y equals mx plus b from your past classes, what does that m stand for? Slope. Perfect. What's the b? Nice. Where is the y-intercept located on the graph? What is it telling me? The y-axis. Okay. A y-intercept, though, isn't just a number. You can't just have the y-intercept be b, because you're looking for a spot on the graph. So if I look on that y-axis, what does x equal all the way along the y-axis? 0. Nice. Everywhere on this line, x is 0, because x is 1 to the right, it's a -1 to the left, it's 0 in between. So whenever you write a y-intercept, you will always put a 0 for x, and then the b value for where it is hitting on that y-axis. So it's always a location on the graph, it's always a point. So when I look at that first equation where it's 3/4 x plus 2, what's the slope? Double check it. Slope. Your m is always next to your x, so your slope is 3/4. What's your y-intercept? 2 is in the b spot, but when we write it, how do we write it as a point? 0, 2. Perfect. How do we graph that? Where do we start? 0, 2. So I start at 0, 0, and I go up 2, and I put a point. From that point, what do I do? Up 3 over which way? Right 4. So we go up 3, right 4. We put a point. How many points did it take to make a line? Ooh, let's think back to chapter 1. 2. So we're done. All you got to do is take your straight edge, whatever it might be, ID card, ruler, edge of a calculator, whatever you have that makes a straight line, and then we draw it in. And then you put arrows at the end because it's a line and lines go on forever. If your graph wouldn't let you go up 3 and right 4, where else could you go? Down 3 and left 4. Good. All right, talk to me about the next one. I have y equals 3x minus 4. What's my slope? 3. Okay, what's my y-intercept? 0, negative 4. So that 0 is always first, and then you got the negative 4 that comes after it. Now, when I go to do slope, how am I going to do a slope of 3? I don't have a rise and a run. Good. When you have an integer, you're always dividing by 1 because 3 divided by 1 is 3. Okay, so from your 0, negative 4, so you're going to start at 0, 0, you're going to go down 4 and put a point. Where do I count from there? Up 3 over to the right 1. Or I could have gone down 3, left 1. Doesn't matter which one you do. I just want to make sure that we talk about it because there's a chance that there might be something on your homework or on a quiz or a test that you can't go one direction, so you got to be able to go the other way. What do I have to make sure I put on at the end? Very nice. All right, go ahead and graph your last two for me. All right, so what is the slope of y equals 1/2 x plus 3? Slope 1/2, I heard back there, thank you. What is its y-intercept? 0, 3. Always a point, I'm telling you that. In Algebra 2, we make you write it as a point as well. It's not a location on a graph unless it has an x and a y coordinate. So I go to 0, 3, and from 0, 3, where do I go? Up 1 over which way? To the right. Up 1 over 2, then drawn in your line. Does it matter how long or short I draw that segment when I draw it? No, because what am I putting on the end of it? which means it goes on forever. So I don't care how long or short it is, as long as we got arrows on the end of it. All right, last one. What's my slope? Say again. -2. What would that be over? Perfect, because you can divide any integer by 1. What is my y-intercept? So where do I go? Okay, down to -1 from 0, 0. Okay. To the right, nice, because down was already negative. So if I go down, I got to go to the right to keep it a positive on that part. Otherwise, I could have gone where? If I go up 2, where do I have to go? To the left. Draw in your segment. And put your arrows on it. Questions? When we turn to the next page, I'm not asking you to actually graph it. I'm asking you to give me directions. Remember the old second or third grade, maybe it was first grade, you have to give directions on how to do a thing, like how to make a peanut butter and jelly sandwich, and you had to start with like get the bread out before you take the knife and you get the peanut butter and then you put the peanut butter on the bread. You got to give me directions. So I want to know how to graph y equals -1/2 x. Well, what did we do on the last one? It doesn't have enough numbers. Okay. Wouldn't it just be a point? No, it's definitely a line. What do we start at? Start at 0. What do you mean? But 0 is just one number. I don't know where to go on a graph if all I have is one number. But I don't have a point yet. There is a slope there, absolutely, but I can't count slope until I have a point. 0, 0. Start at 0, 0. Why is it 0, 0 that we're starting at? We got to make a point, but where does the y-intercept come from? Where in the equation? It's b. It's after the y equals because I should have mx plus b. But what's getting added? Nothing. There's where the 0 comes from. And then we put the 0 in for x because every y-intercept is 0b. Okay, so we start at 0, 0 and put a point. Then what do we do? Count down 1 and over and to the right. And do what after I've counted down 1 and to the right 2? And make a point. Now what? Draw a line. Draw a line where? Through the 2 points. Not quite as bad as doing a peanut butter sandwich, right? Do less directions. But the key is remembering that you're given directions as if someone knows how to work out a graph, but doesn't know how to graph a line. So you had to find the y-intercept for them at 0, 0, and then say put a point there. After we put the point at 0, 0, we need to count down 1 and right 2. So we can put another point, and then we're going to connect them with that line. Questions? So really what it was is trying to get you to verbalize what you did on the front side. All right. Y equals 5. Where does y equal 5? Up 5 over 1. So here? Yeah. Y equals 5 there. I'll give you that. That's at 1, 5. Y is 5, sure. Start at 0, 0. Does y equal 5 there? But y has to equal 5. So 0, 0 is not on my line. Y 5 and not over 1. So right here. What point is that? 0, 5. Y is 5, I agree. Give me another point. Negative 1, 5. Sure. Do you see the pattern yet? It's a horizontal line. Absolutely. So y equals a number is horizontal. It has a y-intercept. It hits the y-axis because y is 5 all the way along that line. What about a vertical? Well, it's going to stay the same all the way along a vertical. The next one, absolutely, because what does x always have to be? What does this tell me x has to stay? 5. Give me some y's that it could be. What could 5 be matched up with? Negative 2, I heard. 0, 1. Absolutely. So if I did 5, negative 2, 5, 0, 5, 1, what will I do to connect them? I put a line through them and it will end up being vertical. So x equaling a number is a vertical line. This is not going to go away. Graphing lines isn't, but in particular, the x equals versus y equals, which one's vertical, which one's horizontal, continually, all the way through this year, all through next year. So you need to get it in your head. If you have to write out points to help you graph it, write out points to help you graph it. But every time you got to be able to tell which one's vertical and which one's horizontal. Why? Because maybe I give you a point like this and I say write the equations for the vertical and the horizontal lines through 3, 2. So up on this other graph, I'm going to put a point at 3, 2. I want to write the equation for the vertical line through that point. If I want it to be vertical, is it an x equals or a y equals? X equals. What does x have to equal to go through that point? It can equal anything. So if I make x equals 10, does it go through that point? But the point's right here. It's got to go through 3, 2. Does x equals 10 go through that point? No. What will make it go through that point? But I'm still vertical. It's a vertical line right now. What is x on that line? 3. X is 3. Because we went through the point 3, 2. So x has to be 3 to have a vertical line go through there. How about to go horizontal? What about 2? Y, absolutely. Y has to equal 2. So going through the point, vertical x equals the x of your point. Horizontal, y equals the y of your point. Okay, so at your tables, you're doing the vertical and the horizontal lines through negative 2, 5. Make sure you identify which one is which. Which one's vertical, which one's horizontal. Go. identify vertical versus horizontal with just a V and an H if you want. All right. I will tell you that when we do this on the quiz, I have it designated to write down vertical and horizontal, so you have to know which is which. You can't just remember, I know that one's x equals and one's y equals. You have to know which one's vertical and which one's horizontal. So what's my vertical line through the point -2, 5? Need an equation. Can't just be a number. X equals -2. What's my horizontal line through the point? Y equals 5. So you got to know which one's your vertical, which one's your horizontal. Now, before you turn the page, there is a question on your homework about the equation of the x-axis and the y-axis. So you may want to stay on that page and write a little extra note on it. So when you get to your homework, you already know how to do this. If I want the equation of the x-axis, is the x-axis vertical or horizontal? X-axis, vertical or horizontal? X-axis. That is a horizontal line. X-axis goes across. What's the equation of that line? Horizontal. So what's it got to be? X equals or Y equals? Horizontal. Y equals. Okay, what does Y equal along that x-axis? 0. Now what about the y-axis? Is the y-axis vertical or horizontal? It's vertical, so it's got to be x equals or y equals? X equals, what does x equal all the way along that y-axis? 0. So again, there are questions on your homework that have that, ask you to give the equation of the x-axis and the y-axis. So you may want to have taken an extra note on that to make sure you have them. When you're done writing that extra note on the top of the next page, I need you to graph y equals 5, y equals -1, and x equals -4. Graphing the lines, top of the next page. As people sitting there staring, what kind of line is y equals 5? Horizontal. Draw me a horizontal line at 5. Horizontal is the horizon. All right, of the ones that you just graphed, which ones are parallel to each other? The what? I'm looking for which lines are parallel. So y equals -1 and y equals 5 are parallel. Agreed. Which ones are perpendicular to each other? What does perpendicular mean? Show me with your arms what perpendicular is. Absolutely. What kind of angles does that mean? They cross at what kind of angle? 90s. Which lines cross at a 90? X equaling -4, and you said both y's. So, and y equals 5. And x equals -4, and y equals -1. Those are both sets of perpendicular lines. Yes? Okay, so if two lines are perpendicular to the same line, y equals 5, y equals -1, are both perpendicular at x equals -4, right? Two lines are perpendicular to the same line, then they are what to each other? Y equals 5 and y equals -1 were perpendicular to x equals -4. What are y equals 5 and y equals -1 to each other? Parallel. So two lines perpendicular to the same line are parallel to each other. All right, and it says in a plane, if a line is perpendicular to one of two parallel lines, then it's also what to the other one? If x equals -4 is perpendicular to y equals 5, what is it to y equals -1? Perpendicular. So sometimes just looking at the picture helps you figure that one out. All right, and then it says, oh, graph a horizontal line through 1, 2. Horizontal line through the point 1, 2. Go ahead and draw a horizontal line through it. That line. Y equals 2. All right. If two lines are parallel to the same line, then they are what to each other? It's a choice, isn't it? Look at your picture. Two lines parallel to the same line. So I've got parallel lines up here. Which ones are the parallel ones? And now we got y equals 2 in there. Wouldn't they all just be parallel? Absolutely. So two lines parallel to the same line, they are parallel to each other. All right, turning to the top of the next page. We have ones like this in your homework as well, so I want you to pay attention to what we have to make a decision on. A, B, C, D, and E are distinct lines in the same plane. For each combination of relationships, tell how A and E are related. They're either going to be parallel or perpendicular. We get to pick what we want to do to sketch right now. Two kinds of lines that are perpendicular to each other are vertical and horizontal, right? And you know that every vertical line is parallel to every other vertical line. Yes? And every horizontal is parallel to every horizontal. So let's pick to make these lines either vertical or horizontal. We start with A and B. It tells me A and B are parallel. What kind of lines are A and B going to be, vertical or horizontal? Flip a coin in your head. Somebody give me an answer. Vertical. There we go. So draw two vertical lines. We're just sketching, so I don't care about arrows or anything else. I'm just going to draw A parallel to B. They're vertical because we picked vertical. Doesn't matter what you pick. But having set those up, when we go to the next direction and it says B is parallel to C, what kind of line do you have to draw for C? Parallel, so vertical, absolutely. All right, now it tells me that C is perpendicular to D. Now it's got to be horizontal, and I'm going to label it D. D is parallel to E. What kind of line is E? Horizontal, because it's parallel to D. Now I want to know, how does A compare to E? Is it parallel or is it perpendicular? Perpendicular. All right, are you okay there? Okay, I'm going to give you about 5 minutes. You have 3 of those to do and 2 questions about slope. Do them with the people at your table, so talk through them together. There are lots of people getting done and getting to those slope questions and just leaving them. Think about the division you have to do for slope. That's what you're trying to talk about in those slope questions. Where do you divide by the 0 or not divide by the 0? All right, for those ones up on top, we got parallel, perpendicular, and parallel. Are there any of them that we need to go through to make sure you got that same answer? I'm going to double check that first one because I saw a lot of mistakes on it. A is parallel to B. What kind of lines am I drawing? I don't care. Vertical or horizontal? All right, A and B. B is parallel to C, so C has to be also vertical. C is perpendicular to D. It's got to be horizontal. D is perpendicular to E. So we got to make that go up and down. So then A and E are parallel. That was the one that I saw. If there was going to be a mistake, it was usually on that one because you were used to the example we had just done. And the one we had just done, D and E were parallel. But this time I had them perpendicular. All right, the last two, horizontal line has a slope of 0. Why? What do we divide for slope? You divide the y's on top, yes? So your rise over your run. Why would horizontal have a slope of 0? Because your y is 0. 0 divided by a number is 0. Okay, what about undefined for vertical? X is 0. You can't divide by 0. So those two questions were really just asking you to kind of analyze the fraction that you got to do to find rise and overrun, to find slope. All right, last bit. On the front page, we graphed using slope intercept. It was in the right form for it. It was in y equals mx plus b. But we don't always give you the lines in y equals mx plus b. Sometimes we give it to you in standard form. Standard form is when you have ax plus by equals c. Just means your x and your y are on the same side. A, b, and c are real numbers. And sometimes when you have that format, it is easier to graph using x and y intercepts. We already know the y-intercept is when x equals 0. So if I want to find it without solving this for y, I'm just going to plug in 0 for x. So y-intercept is when x equals 0. So in this equation, I'm going to put a 0 in for x. When I put a 0 in for x, what happens to that first term? What is 6 times 0? 0. So I can kind of cross it out, right? So it's not going to make any difference if it's 0. So I get to 3y equals 12. What's y? Dividing by 3. 12 divided by 3. So that's a number, but remember these are always points. The point is what you plugged in for x, which was 0, and what you got back for y, which is 4. So your y-intercept is when you plug 0 in for x. Your x-intercept is when you plug 0 in for y. So we're going to have the 6x plus 3 times 0 equals 12. But again, what happens when I take 3 times 0? It goes bye-bye, it's 0. So really, I have 6x equals 12. So x is 2. Okay? So the x is 2. What did I plug in for y? The 0. So your x-intercept is 2, 0. Then we graph those 2 points. 0, 4, start at 0, 0, go up 4. 2, 0, start at 0, 0, go right 2. And then we draw on our line. What do you put at the ends? Beautiful. Using your straight edge, hopefully your straight edge is more accurate than mine is. When you do this, the work I need to see at this point, we'll let you shorten it later, is at least showing me this step where you've zeroed out the other one and you show me what your 6x equals 12 and your 3y equals 12. I don't care about any of the other work that would be involved. You can do mental math on it. But for today's assignment, I want to see when you zeroed it out what was left in the equation. Okay, and then you got to show me the 2 points. Good? Understand what happened? Okay, do the one on the bottom. Yes. Y is when x is 0. X is when y is. Looks like most people are there. Tell me what you got for your y-intercept. 0, -2. One of the questions that came up is the order of those points important? Yes. You got a y of -2, it's got to go in the y spot. You put 0 in for x, that's got to go in the x spot. When I'm over here, I have -2x is going to equal -8 because we zeroed out the y. So you get x equals 4. So what do I write for a point there? 4, 0. Important because that tells me where to graph that point. When I have 0, -2, and 4, 0, you get the line going this direction. One thing I noticed was -4. Make sure to double check your mental math. You had 2 negatives being divided there. Negative divided by a negative is a positive. All right, so when you are looking at the homework, remember that you always have to show me work. So the first one has 3 different slope problems. You have to show me the work for each of those slopes. And don't forget that you also have to reduce slope. When you are asked to find the x and the y-intercepts, please make sure you show the work like I just did on that last one, where you show me what you get when you zero out the one variable.